Hello guys, my group is the makeup Diego Granados and Manuel Navarro and Felipe Rodriguez. We will give an explanation to the weather papers with the made hard cross exercise using in the crossmate the operation of the main pipe of the water distribution. The system is sound in the figure 1. The water demanded of the system domestic curve is the 522 and is the supplement and point I and E. The most unfavorable for loss pressure is the assuming that the demand for water in the cause of fear plus the required domestic flow is 204 and other points on the direction in the estimate that the quantity.
Hello, my name is Sebastián Navarro and we are going to talk about the flow distribution. The flow distribution is, as we can see in the picture, all the distribution of the flow that we made. We talk about this, and for example, for some of these flows, these are divided in some parts that are represented by the red arrow or the red lines. For example, in the node A, the flow that goes in is divided into parts, and it's important to say that for the whole system each node satisfies the node's law. For the next part is the next part is the mesh law, and in the mesh law we assumed the diameters, as we can see. For example, in the yellow section we calculate the friction factor and all the losses for each circuit. For example, for the circuit 1, circuit 2, for the circuit 3, and for the circuit 4. In each yellow section is a assumed diameter, and we made the same process, the same analyzed for each circuit, calculating the friction factor and the losses in all of these circuits. So now for the delta Q or the delta flow, we have to correct this flow. We analyze and calculate delta flow that is like a differential, and we calculate with this equation right here for the Hardy cross method, and we calculate delta Q or delta flow and a corrected flow for each circuit, as we can see in the images. So this process was repeated like for 20 times. Okay, so in the iteration number 20 we can see here the losses for each circuit, and for the restriction that we had before, we could see that the section BC that is marked with a yellow section is over the restriction, so it doesn't work for this solution, and we decided to correct the diameters in the mesh law again, for not for each circuit. For example, the circuit 1 is the same, but for the other circuit Yes, we had to do this to recalculate or to calculate again the friction factor and all of those things like losses and stuff. Then we corrected all the losses again with the equation of the Hardy-Cross method, and as we can see they are corrected right here, and for the final results are that the losses for each section like AB, BC, CS, FI, all the losses are under the restriction. So the restriction that we mentioned before is that for 2 meters of loss are for each 1,000 meters of pipeline. Okay, so in the results are correct. We could conclude that.
Alright, then we did some calculations to find the pressure in each node that you can see in this picture. So first we did the conversion of units to work in the international system. After that we use the energy equation, and as can you see we cancel the term of speed, assume that the speed was the same throughout the pipeline. So assume this, we cancel the term, and we find this equation to find the pressure at the node B. Using this equation, we find different pressure of nodes. For example, we find that the pressure in node B was 27 psi, the pressure in node C was 30 psi, in the node D was 27 psi, in the node E was 33 psi, and in the node F was 28 psi, in the node G was 24 psi, in the node H was 30 psi, and finally we find that the pressure in node I was 25 psi. So we did research, and we find that in case of fire, the pressure required in pipeline must be at least 20 psi. So as can you see here, we find that the pressure of our system was in the node E was 25 psi. So we can say that the system that we create, that we design, is or it can be used in case of fire. Thanks for your attention.